Okay, this is paper 1, question 5. It's an indices question with a bit of scientific notation added into it as well. So I suppose it's kind of a number question, really. So it says, write 8 and 8 to the power of 3 in the form of 2 to the power of n, where n is equal to a natural number. Okay? Or sorry, where n is an element of the natural number. So basically, it means that this little n here has got to be any number but from 1 to infinity. Okay? So 8 is very simply written as 2 to the power of 3. Okay, that's fairly straightforward. 2 by 2 is 4, 4 by 2 is 8. And over here we have 8 to the power of 3, and you need to write that as 2 to the power of n. Okay, so, well, you know that 8 is equal to 2 to the power of 3, and all of that is going to be to the power of 3. Okay, which is the equivalent of 2 to the power of 3 multiplied by 3, which is equal to 2 to the power of 9. Okay? Okay, so part B says, hence or otherwise solve for x, the equation 8 to the power of 3x is equal to the square root of 64. Right, well, first of all, you know that 8 can now be written as 2 to the power of 3, so it becomes 2 to the power of 3, bracket, 3 to the power of x, or sorry, 3x, so 2 to the power of 3, and all of that is to the power of 3x, is equal to the square root of 64, which you should know is 8, okay? And using the laws of indices, this is going to become 2 to the power of 3 multiplied by 3x, so 2 to the power of 3 multiplied by 3x, which is equal to 2 to the power of 3. Alright? Which means that 3, we can cancel our 2's here. 3 by 3x is going to equal 9x is equal to 3. X is equal to 3 divided by 9. Okay, so x is equal to a third. 1 over 3. Okay. Okay, so part C says, Earth and Mars follow 2 separate orbits around the Sun. When they reach their nearest point, the 2 planets are only 54.6 million kilometers apart. Only 54.6 million kilometers apart. Write this distance as a whole number in meters, and then in the form a by 10 to the power of n, where 1 is less than or equal to a, and a is less than or equal to 10. That's just a way of saying, make sure that this little n is between the numbers 1 and 10. And where n is an element of z, which is integers, which means that now you can have, it could be negative numbers, but that's kind of ironic because you won't get a negative number really. So correct the 2 significant figures. Alright, so first of all, it's 54.6 million kilometers, right? So we have to convert 54.6 into million, so multiply that by a million, okay? Which is going to equal 54,600,000 kilometers, okay? Now we need to get that into meters, so multiply it by 1,000, because there's 1,000 meters in a kilometer. And you just add 3 zeros on, so you should get 54,600,000,000. 54,600,000,000, yeah. Okay. And so that's how many meters there are. Now you're asked to put this to significant figures, 2 significant figures. So these are my 2 significant figures. That 6 is closer. That 600 million makes this 54 closer to 55 billion, right? So I'm going to change that to 55 billion. Okay. So 55 billion meters. And now we have to write it in the form of a by 10 to the n, which is scientific notation. Alright. So your decimal places here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5.5 by 10 to the power of 10 meters. Okay. Okay, so part 2 of part C says, to determine the distance between the 2 planets, a light beam is aimed at Mars, and the time it takes for the light to travel to Mars and to be reflected back is measured. Given that the speed of light is 3 by 10 to the 8 meters per second, find the minimum time it would take for a light beam to travel to Mars and back again. Correct to the nearest second. Well, this is a distance or distance speed time question. So we're trying to find the time, which is equal to distance divided by speed. Okay. And let's look at what we've been given. Well, we've been given the distance, which we worked out to be 5.5 by 10. 5.5 by 10 to the power of 10 meters over 3 by 10 to the 8 meters per second. Okay, so that's really important that we had converted this to meters, because if we didn't, then we have to convert it now, because you can't divide meters by kilometers per second or anything like that. So this is a distance in meters divided by a speed in meters per second. Alright, so when you actually put that formula in and you divide it out, you should get 1.8333333 dot 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 dot, right, it goes on and on, multiplied by 10 to the power of 2. So in other words, you get 183.3333 seconds. Okay, so basically we've worked out that it takes the light beam to 183.333 seconds to reach Mars from Earth. But now we have to talk about going to Mars and then back again. So you multiply this by 2. So multiply 183.333 seconds by 2, and you should get 366.6666 seconds. Okay. Now it says find the minimum time for light beam to travel to Mars and back again correct to the nearest second. So this is closer to 367 seconds. And that is the answer there.